Hi class, I wanted to make a little video about how to solve a problem similar to what I'm asking you to do for topic 6DQ1. You're trying to solve an inequality involving a linear expression over a quadratic expression. And this topic's work is on the quadratic expression, so the main point is sort of the denominator here. Okay, so I've made up a Desmos page that I send you to, and it will generate you a problem. Okay, so initially it'll look like this, where this is just an empty list. And then you're supposed to randomize this and get a problem. And you can generate lots and lots of problems so you find one you like. None are particularly different from any others. The way you do these are all the same. But you can see that these give you quite a few shapes of problems. Sometimes you might have to zoom out and move things around to see where things are. But you can see you get quite a few different shapes of graphs from this fairly simple thing, just a linear over quadratic. Okay. And all of these, in all of these, we're trying to solve this inequality where the function is greater than or equal to 0. And the thing you want to notice here is that, in order to go from, say, here being negative to being positive, if this were to ever become positive, it would have to go through the x-axis. So it would have to actually hit the value 0, right? Now this is only going to have one actual 0. It's going to be the 0 of the numerator, right? So this will never hit 0 out there. And this is positive. This will never go negative because it will never hit 0 out there. This is the only place it hits 0. Now it can't jump from being negative to positive, or I guess here they're both jumping from negative to positive, so it can also jump from positive to negative. And that will happen at a place where you have, this vertical kind of asymptote here. And that's when you're dividing by 0. So that's sort of a problematic spot, okay? So basically the trick of these problems is to find out where the numerator is 0 and factor the bottom, and then look at the two zeros of the denominator here, and that'll correspond to these places that are not in the domain of the function. And what happens then is you break this line up into pieces. It'll have a piece, sort of over here. You're going to get 3 points, right? You'll get 2 points from down here. Depends a little bit on your problem, but generally 3 points. You get two points from down here and a point from up here. And those 3 points will divide the line up into 4 intervals. This part over here, in this case, this part here, and this part over here. And what you want to do, there's a few ways of doing it. And what I'm going to do here is just sort of look and see, is the top positive, is the bottom positive or negative, and then use, common sense things about products of two negatives is positive and stuff like that. Okay, so let me go back to the problem that I originally had in here. Okay, so this is the problem I originally had. And if we were to factor the bottom, we would get x plus 2 times x plus 6. That's what the bottom would turn into. Sorry, x plus 2 times x plus 4. That's what the bottom would turn into. And its two roots would be minus 2 and minus 4. Okay, so I can regenerate this same example by coming here to this list. So I'm going to put in the 4, I'm going to put in the 1, and I'm going to put in those two roots, minus 2 and minus 4. So this will be useful if you want to go back and regenerate your problem. So minus 2 and minus 4. Okay, and then there's that problem again. You can see it's the same, right? 4x plus 1 over x squared plus 6x plus 8, right? Same thing. You can see the graph is the same, right? So we can go back and regenerate problems like that. Okay, before we start working on it, let's look here. Actually, I'll use this Desmos version. We can see here that that this is positive here between minus 4 and minus 2, right? And those 2 points are not in the domain. Okay, and then it's positive from here where the root is all the way out. Now it may not be that easy to see where the root is. You can go in and guess, but on the other hand, the root's going to be right at the root of this linear on top, right? And so that's going to be 0 at x equals minus 1/4, right? So this is actually minus 1/4 on, okay? So this is supposed to be here to check your answers or at least so that when you do the work, you know that you have the right answer. Now, initially when I made this, I had a mistake, and that confused some people. Um, and it's not surprising it confused some people because it was wrong. But here it's right. Okay, so we know before we even start doing any work that this interval going out here is going to be the interval. It includes this endpoint and then minus 1/4 and going on to infinity. So we're going to include that. And then we pick up this little interval here, which is -4 to -2. Okay, and it's going to be the union, right, of those two intervals. Okay, so that's what our, oops, and now I've already made another mistake. Um, those points are not in there. Okay, don't go too far. Okay, so I want that. Sorry, these 2 points -4 and -2 are not in the domain. So I want those to be these round intervals. In my interval notation, I want them to be, the rounded parentheses here, right? So our final solution we know is going to look like that. Okay, so let's do the actual math, right? So I'm trying to solve 4x plus 1 over x squared plus 6x plus 8 is greater than or equal to 0. Now, something you obviously can't do. This is the kind of thing that happened a lot on topic 4 or week 4 DQ2. We can't just multiply by the denominator, right? Because then, if we did that, like if we just did this, sort of borrowing your notation here, where we multiply an entire equation by something, right? But if I just did that, then what I would end up with is 4x plus 1 is greater than or equal to 0, right? This whole piece just disappears because 0 times anything is just 0. And then I would just get x greater than or equal to -1/4. Okay, so that's part of our solution, but that's definitely not all of our solution. So, this is no good. That doesn't work. What we need to do is more algebra, right? We need to actually write down this thing factored, right? So the way we're going to do this is we look at 4x plus 1, and then let's factor this thing into x plus 2 and x plus 4. That's how this factors. You want this to be greater than or equal to 0. Okay, and basically this has, 3 factors. It's got this, this, and this, and those can be positive, negative, in combinations of those things, right? And so that's basically what we're going to look at. And where can they change signs? Where would this turn from positive to negative? Well, we do it at -1/4. Where could this turn from positive to negative? Well, it could do it at -2. Where would this turn from positive to negative? Well, it would happen at -4, right? So basically, we just need to find the sign of this thing at those various places. Okay. I think I'll just write on this graph here. Okay, so we can just check, right? So one of our intervals is out here, right? So this is at -4, right? And let's see what happens. So we can pick a point, and I mean, I'll actually pick points, sort of like I do in the write-up, but I'm not going to worry about evaluating it. I'm just going to check positive or negative. So out here, if I put in -10, right, this whole top part up here will be negative. So what I'll have is a negative divided by, this would be like -10 plus 2, that'll be negative, this will be negative, right? So I have a negative times a negative, whoops, and the whole thing, right, is negative, right? And so we can do that again here. So if I take a point in here like -3, right, this will be negative, that'll be positive, this will be negative, right? So this is going to look like negative over negative positive, right? And so this will be positive. Remember, wanting greater than or equal to 0, so that's good. We'll take that interval. If I take something in here, right, so something in here would be like -1, right? And if I put in -1, that'll be positive, that'll be positive, this will be negative, right? So the whole thing will be negative. So again, the reasoning is negative over positive, positive, right? So this will be negative, okay? And then finally, stuff over here, I can take something like 10, right? So that'll be positive, that'll be positive, that'll be positive. So this will just be a bunch of positives, right? So positive over positive, positive, right? That'll be positive. Okay. So we can see from checking this that we're going to include this interval over here. We're going to not take that interval there. We're going to take that interval there. That was positive. That was good. All right, and then this is negative over here. We're going to not take that interval. Remember, we're testing this sign. We're going to be greater than or equal to 0, right? So by doing this, we've actually accomplished what we wanted here. So so this is the way you do the problem. Now, this is not a nice write-up of the problem. This is just, this is sort of my scratch work here and talking to you. I wrote it up sort of nicely in the actual write-up, and so you need to do that too. And that's basically what we need. Thanks.